f of wxyz is equal to sigma m of 4, 5, 7, 8, 10, 12 and 15. The input to I1 and I3 will be, so here one multiplexer is given. That multiplexer is containing 4 inputs with 2 selection lines, I3, I2, I1 and I0, and I2, I0 are fixed, where I2 is equal to the complement of the external input Z, and I0 is the ground, that means is always 0. So based on the selection lines, we have to get the output f. This is sum of min terms, that is 4, 5, 7, 8, 10, 12 and 15 should be equivalent. Then we need to find out what should be the value of I1 and what should be the value of I3. Normally I1 will be selected only normally the cases. For example, if we take S1, S0, 0, 0, 0, 1, 1, 0, 1, 1 in a normal multiplexer operation, the output is equal to the first I0 when the selection lines are 0, 0, I1 when 0, 1, I2 when 1, 0, I3 when 1, 1. So that means, so these are selection lines are taken from the external inputs W and X. So we need to find out I1, the value of I1 and I3. So the I1 and I3, I1 value W dash X and I3 value WX. Because both are ones, we need to select I3. That means this if you take a truth table like W, X, Y, Z, what are the minterms producing ones in the combinations given? For example, W dash X, that means 0, 1. So YZ can be either 0, 0, 0, 1, 1, 0, 1, 1. Similarly, when WX is 1, 1, we can take a combination 0, 0, 0, 1, 1, 0, 1, 1. So these combinations you have to see, because those are fixed. That I2 is fixed and I0 is fixed. So for this, this 0, 1, 0, 0, that is 8, that min term is 1. Again 9, 0, 1, 0, 0, 0, 1, 0, 1. This is 4 actually. 0, 1, 0, 0 is 4, that is 1, that is output, and 0, 1, 0, 1 is 5, that is also 1. Again 0, 1, 1, 0, 6, that is not there, that because in this given value 6 is not there. Again 0, 1 or 1, 1, it is 7, 7 is there. So these are the min terms 1. For this one WX combination 1, 1, 0, 0, that is 12, that is 1. Again 0, 0, 1. So making use of the Karnaugh map, we can find like this the simplified value of those. Say for example, if you take W, X, Y, Z like this, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. So 0, 1, 0, 1 is 1, 0, 1 is fixed, and again 0, 1, 0, 1, 0, 1, 0, 0 is also 1, 0, 1, 1, 1 is also 1. So for this the mapping will be these two and these two. W dash X is fixed now. So in the form of Y and Z, it will be Y dash plus Z. So this factor, that is which is equivalent to I1, it is Y dash plus Z. I3, what is the value? 1100, 1100 is this, and 1111 last, this is this. So this one and this one, if you fix this, X, Y dash, Z dash plus YZ, that means it is exclusion R, that is Y exclusion R Z. So I3 should be Y exclusive or not Z, and I1 should be Y dash plus Z. So it will be option B. Then only we will get this simplified format equivalent to F. CPU supports 4 interrupts I1, I2, I3 and I4. It supports priority of the interrupts. Nested interrupts are allowed if a later interrupt is higher priority than the previous one. That means while you are executing one interrupt service routine, if any other interrupt is arrived, then definitely higher priority interrupts will be serviced, so that the interrupts can be executed in nested order. During a certain period of time, we observe the following sequence of entry into and exit from the interrupt service routine. So some sequence is given. I1 started first, again parallelly I2 is also started after some time. That means I2 might be higher priority than I1. While after execution of I2, after I2 is ended, then I4 is started. And while I4 is executing, I3 started and I3 is ended. After that I4 finished because I4 is started now before I3. In meanwhile, while you are executing I4 interrupt service routine, then I3 has come and I3 is finished, I4 is also finished. Then finally I1 is finished. That means from the above sequence, what we can infer about the interrupt routines? That means I3 is greater than I4 is greater than I2 is greater than I1. Next is I4 greater than I3 greater than I2 greater than I1. Option C, I2 greater than I1 colon I3 greater than I4 greater than I1. Option D, I2 greater than I1 colon I3 greater than I4 greater than I2 greater than I1. So here from this one thing we can say I1 is started, parallel I2 is started. Definitely I2 is higher priority than I1. Otherwise I1 should have been continued if I2 is not higher priority. That means I2 is greater than I1 is confirmed. But in option A, I2 is greater than I1 is there, but at the same time I4 is greater than I2 it is given. That is wrong because parallelly while you are executing I4, I3 started. Then I3 is greater than I2. While you are executing I4, that is I2 is ended, I4 started. Then while you are executing I4, I3 started. Then definitely I3 is greater than I4 and I4 is ended, I1 is also ended. So that directly we can't infer because there is no direct relation between I1 and I4. Between I1 and I4. So that's why, so I2 greater than I1 is correct first. Again I3 is greater than I4 because while you are executing I4, I3 started. Definitely I3 should have been greater than I4. There is no relation directly between these two things. That is why we can't take this option A. Then option B, I4 greater than I3 greater than, that is wrong because I4 is not greater than the I3 because while you are executing I4, I3 is executed. No, I3 should have been higher priority. Now I1 is ended. Finally I1 is ended. Okay, that means I1 is lower priority than all others. That is I2, I3 and I4. But we can't say I4 is greater than I2. Why I4 is greater than I2? Can't say. There is no direct relation. That is why I3 is greater than I4 because we stopped I4 while you are executing I3. So I4 is greater than I1 because while you are continuing I1, I4 has come. Otherwise I1 should have been continued if there is no I4. So I4 is greater than I1. So option C is the right option here. A stack oriented processor that includes the stack operations push and pop. Begin with an empty stack. Following instructions were executed: push 4, push 15, push 10, add, push 9, subtraction and multiplication. What is the content of stack after the above instructions are executed? So the first instruction is push 4. The content of the stack will be 4, top of the stack. This will push the content into top of the stack. Now push 15, the 15 will be pushed. Now push 10, 10 is on the top of the stack now. Again add, what will be added? 15 is added to 10, then it will become 25. Now top is 25. Again push 9, the 9 will be the top of the stack. Subtract 25 minus 9, it will be 16, 16 on the top. Actually when you have some a minus b, a b minus, a will be pushed, b will be pushed, so b should be subtracted. That means always top should be subtracted. You won't get negative value. That is 25 minus 9. If it is 9 minus 25, you will get negative value. So 4 and 16. So finally on the top of the stack 64 will be there. Option A is the right option here.